Welcome, welcome, second grade students. Today we're working on science in the Unit 6 Force and Motion, Lesson 8 Force and Motion portfolio. Even though you turn in this portfolio during Lesson 8, you will begin the activities needed for it in Lesson 7. That means you should take at least 2 to 3 days to complete this entire portfolio. Don't rush yourself and try to complete it all in one. So let's begin with your directions in Lesson 7 to help you get started. Objective and key words. In this portfolio, you will think like an engineer about using ramps to make a toy car move a long way. So that's our objective. That means that's what we are going to do. Our key words are energy, which is the ability to move or change something, friction, a force that works to slow down motion, gravity, a force that pulls objects toward Earth, and ramp, a flat object with one end that is raised higher than the other. Think like an engineer. In this portfolio, you will think like an engineer. Engineers follow steps to solve problems. So in this portfolio, we are going to go through all of these steps, asking questions, brainstorming, designing, creating, testing, and improving. On page 13 in your Science 2 resource book, you can look at this anchor chart as a guide if you need to. In this part of the portfolio, you will learn about roller coasters and ramps. This will help you complete the portfolio. Have you ever been on a roller coaster? What did it feel like? Read You're on a Roller Coaster to learn about them. So right here, if you click this, you can read. And right here, if you click here, it will read the audio and you can listen to it. Engineers ask questions when they design a roller coaster. That is the first step in the engineering design process. Here are some questions they might ask. How do we make the roller coaster go fast? What forces affect a roller coaster? How do we keep people safe on a roller coaster? Look at that super cool picture. A ramp is a flat object with one end that is higher than the other. It is like a hill. Here's a picture of a ramp. It says ramps are great for helping people who use wheelchairs to get around. Going down a ramp is a lot like going down a roller coaster. When a roller coaster car is at the top of the track, it has stored energy. A toy car at the top of a ramp also has stored energy. The higher the track or ramp, the more stored energy. The same forces act on a roller coaster car and a toy car on a ramp. Gravity pulls them both downward. This makes them move. Friction between the roller coaster car and the track slows the car down. Friction between a toy car and a ramp slows the car down. Imagine you want to win a contest. In the contest, you will let a toy car go at the top of a ramp. The toy car that goes farthest wins. There's just one problem. You do not know the best way to make a ramp that makes the car go farthest. You need to solve this problem. To do so, you can think like an engineer about ramps. In this portfolio, you will design a ramp to make a toy car move far. So here's everything you're going to include in your science journal. We're going to ask questions about ramps, brainstorm how to test ways to make toy cars move a long way, design ramps to test ways to make toy cars move a long way, create ramps by following the design, test the ramps, and improve your design to make the toy car go even farther. So throughout this portfolio, we'll be using your science journal to record each one of those steps. So let's go ahead and look at the very first step, which is ask questions. This is my science journal. It might not look the same as yours, but that's okay. The work will be the same or very similar. So here are my two questions. They're probably different than the questions you have, and that's okay. Any question you have about ramps is fine. So I wrote, can a ramp be too tall? And how do objects slow down on a ramp? I saw that it said something about friction, but what does that mean? Let's go back to your lesson. You will complete your journal and pictures of your work. You will send them to your teacher. All right, we've got a new objective. In this section, you will brainstorm ways to test ramps to see how they change the speed and distance toy cars move. Here are our key words. Height means how tall something is. Surface is the outer part of an object, and a ramp is a flat object with one end that is raised higher than the other. In this part of the portfolio, you will brainstorm possible solutions to a problem. This is an important step. So we've asked our questions, 2 or 3. Now we're going to brainstorm. What are some of the possible solutions? Remember that your goal is to test ramps. You will see which ramp height and surface makes a toy car go the farthest. You will brainstorm possible solutions to this problem. When you brainstorm, you list all of your ideas, then you will choose the best idea. Here's a podcast that you can listen to. It might give you some ideas that you could use with your ramps. And here are some questions you can talk about with your learning coach to help you with your brainstorming. All right, so let me go ahead and show you what I have for my brainstorming. I wrote, I can build ramps taller and shorter so I can change the height. I can build ramps out of different surfaces, so different materials that make the exterior or the top part different. And I want my ramps to be like real roads. So when I test them with that toy car, I want to make it similar to what a real car would really be driving on. So here are some of my ideas. I've got a shorter ramp. I've got a taller ramp. And then right here, I thought maybe I'd like to add some dirt onto one of my ramps or some sand, something to make it kind of like a dirt or a sandy road. I thought that would be really cool. All right, here's your lesson. There are 2 things you will test. You will test how different ramp heights affect the toy car, and you will test how the ramp surface affects your toy car. Only test one thing at a time. First, brainstorm a way to test the effect of ramp height. How will you build ramps of different heights? Next, brainstorm a way to test different surfaces. How will you make ramps that have different surfaces? Think about the rough and smooth materials in the flip book. Then make a list of your ideas. So here are some sentence starters that can help you with your brainstorming. You could write, to test how different ramp heights affect a toy car, I can, and then you write your answer. To test different ramp surfaces, I can, and then you'd finish your answer. Or another idea is dot, 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 and then you would finish your answer. Remember, you can write some sentences and you can draw some ideas for your brainstorming portion. Here's a new objective. In this section, you will ask questions about how using ramps changes the speed and distance a toy car moves. Here are the key words. Distance is how far something moves. Friction is a force that works to slow down motion. Ramp is a flat object with one end that is raised higher than the other, and the surface is the outer part of an object. In this part of the portfolio, you will ask questions about using ramps to make a toy car move. This is the first step in the engineering design process. So this lesson was a little bit out of order. We actually already did ask because ask is the first portion that comes before brainstorming. So right here, if you've already asked your questions, you don't need to do that again. I just did it in order because it looked like the lesson was a little bit out of order this time. Remember, your goal is to test ramps to see which ramp makes a toy car go the farthest and the fastest. You can start solving this problem by asking questions. You will ask questions about ramp height and ramp surfaces. So if you haven't done that yet, you can do that now. Let's read a little bit about ramp height. Ramps have one end that is raised. The raised end can be high or low. Some ramps are steep. They have one very high end. They get higher quickly along a short distance. Some ramps are not as steep. The raised end is not very high. There is less change in the height over the ramp's distance. So here is an example of a very steep ramp. You can see it's very high. And here is an example of a ramp that is not very steep. It's lower at this end, right? It's not as tall. Ramps can be made of different materials. They can have rough or smooth surfaces. The surface of a ramp is the outside part of the ramp. This is the part the car's wheels will touch. Watch this flip book to find out more. Definitely watch this. This is going to give you a lot of great ideas. Remember that friction is a force between 2 surfaces that are touching or rubbing. It works against motion. It slows things down. The kind of surface affects the amount of friction. A rough surface makes more friction. A smooth surface makes less friction. It is hard to pull a wagon across grass. It is easy to pull a wagon across a kitchen floor. Think about the problem you want to solve. What questions can you ask about the surface of a ramp? Here are some great questions that you can read and go over with your learning coach. Okay, so now make sure in your Ask Questions sections that you have asked questions about how different ramp heights might affect the motion of a toy car and how different ramp surfaces might affect the motion of a toy car. Here are some question starters if you need them. Will a low or high ramp blank? Which kind of surface will blank? To make a toy car go fast, what blank? So you can use these if you need to help you ask your questions. If your questions are different, that is absolutely fine. So this is a great stopping point if you want to do this over 3 days. If you want to do this portfolio over 2 days, I would keep going a little bit further. But if you've gotten to this point and you feel like you're done for now, just doing the ask and the brainstorm sections is fine for day 1. We're going to go ahead and move on here. This would be day 2 if you're going to split this up over 3 days. It'd still be day 1 if you're going to do this experiment just in 2 days. Here's our new objective. In this section, you will design ramps to test which height and surface will make a toy car move the farthest. Here are the keywords. Implement means to put a plan into practice, to actually do the plan. Innovation is a new idea or way of doing something, so something that's very creative. Surface is the outer part of an object, and a ramp is a flat object with one end that is raised higher than the other. In this part of the portfolio, you will design and create your ramps. These are the next steps in the engineering design process. In this design step, you will use the ideas you brainstorm to make a plan. You will list the materials you plan to use, and you will list the steps you need to take. So you can ask yourself, what is the best design? What is the best design for your ramps? Use your ideas from brainstorming. Here are some things to think about as you design your ramps. You must test ramp heights and surfaces separately. When you test different changes, you only test one change at a time. Make a plan to test different heights first. For example, you can test a low ramp, a medium ramp, and a high ramp. Then make a plan to test different surfaces in a similar way. Here are the things your plan should include: the materials you need, how you will make the ramps. So here's an example of my science journal. And here is my design section. I have the materials I'm going to need. I'll need cardboard, toy cars, books, sand or dirt, a small rug, and tape. So I decided for my height, I was going to make my ramp taller or shorter by using books. And I'm going to stack more or less books depending on the height. For my surface or the friction, I wanted to add sand or dirt to one of my ramps, and I wanted to add a small rug to one. I thought, hey, I've got rugs in my house, and they're kind of fluffy like grass. So one of my ramps will be like driving on a dirt road. One of my ramps will be like driving through grass, and my original cardboard ramp will be like driving on a road. So I'm going to test friction and surfaces with those. All right, and then I'm not sure if I said it or not, but tape. I'm going to tape my cardboard onto my stack of books. That way it doesn't wiggle and fall off. I don't want that to affect my test. Here's my plan, and here are the steps in it. Number 1, build a tall ramp using many books. Number 2, next, remove some books to make the ramp less steep. So I'm going to test it when it's really tall, and then I'm going to take some of those books away and test it again. Then repeat step 2. That means I'm going to take even more books away to have a really low ramp. Number 4, record how far the toy car traveled on each ramp. Number 5, build a medium height ramp again. So remember, you don't want to change the ramp's height when you're testing the surface. So for my surface tests, I'm going to use a medium height ramp every time on all 3. Then I'm going to test it with only cardboard, then with sand added, then with a rug added. So I'm going to do that in step 6. My last step is step 7. Then I'm going to record how far the toy car traveled on each surface. So here is my height test. I showed what each one of my ramps will look like. Here's my surface test. And I showed that I'm going to use a medium ramp each time, but I'm going to change the surface. Just cardboard, adding some dirt or sand, and adding a fluffy rug. So remember, you're going to test height And you're going to test that friction and those surfaces in different experiments. All right. After you have made the plan, you can implement your innovations. Your innovations are creative ideas you came up with. When you implement them, you create ramps based on your ideas. So we've designed, we know our materials, we know our steps. Now you're going to create. You're actually going to start gathering those materials and building that ramp or those ramps. Think about the steps that you will follow. If you have an extra step that you need to add, that's okay. Sometimes when we start building something, we realize that maybe we need to do something else we didn't add, and that's fine. You can always add that later. Here are some questions that you can talk about with your learning coach about your ramps. Now create a design and a plan to test different ramp heights that will affect how far a toy car goes and test how different ramp surfaces will affect how far a toy car goes. Make a list of the materials you need and gather your materials. So if you want to do this on the next day of your portfolio, just get those steps written out, get those materials gathered. You might have to go get a toy car if you don't have one. All of that good stuff, that's a good stopping point maybe for day 2. If you want to keep going, you can go ahead and start building those ramps. So here are some guiding questions or some sentence starters that you can use for your design and create section. Remember, you can draw pictures as well. So you could say, to test the effects of height, I will, dot, dot, dot. To test the effects of ramp surface, I will, dot, dot, dot. And the materials I will need for my investigation are, and you could add them in a sentence form like that. Finally, you will follow your design to create the ramp. So this isn't the last part of your experiment and your portfolio, but we are getting there. So you might want to do this on day 2. You might still be doing this on day 1. That's fine. Now we're going to go ahead and move on to lesson 8. This is going to be the last couple of sections that you are going to turn in. So you might want to save this for day 2, day 3, whatever works best for your schedule. Here's our new objective. In this section, you will decide how ramps can cause a car to travel farther by testing and recording different heights and surfaces. The key word is measure, which means to learn the size, amount, or degree of something. So that means you'll need something to measure the distance with. There are some examples we'll go over in your lesson in a moment, and I'm also going to show you some that I had at home. So this is a yardstick. That means it's going to have inches that are the primary unit of measurement. This one is very similar, but this is a meter stick. So the distance is slightly different and it has centimeters as the unit of measurement. I also have a tape measurer. So if you have something like this, you can use a tape measurer as well to measure the distance. Whatever works best for you, whatever you have at home is fine. Just make sure when you record the distance that you use the same unit of measurement each time. Inches, centimeters, feet. Make sure it's the same unit for all of your tests. All right, let's go back to your lesson. In this part of the portfolio, you will test your design. This is an important step in the engineering design process. When you're doing your test, ask yourself what worked and what didn't work. In this last part of the portfolio, you created your ramps. You made a plan to test them. Now you will use the ramps to test how ramp height and surface affect a toy car's motion. To test each ramp, place the toy car at the top of the ramp. Let it go without pushing it. When it comes to a stop, measure how far it went. Measure from the bottom end of the ramp to the front end of the car. So here are some tools. This is a long ruler or a meter stick. And remember, there are some others you can view in the gallery here as well. Whatever you have at home to measure with is fine. Each time you measure, record how far the car went. One way to record all of your measurements is to use a data table. Your data table might look like this. So in this data table, they used bricks to change the height of their ramp, and the surface, they used foil, plastic, and paper. So you can use a data table just like this. I used one as well in my science journal, but I changed the interior columns a little bit and the interior rows because I use different materials. So for my height, right over here in this column, I have 2 books, 4 books, or 6 books. I didn't have bricks, I used books. And then when it says how far, I measured using inches. So with 2 books, my car traveled 44 inches. With 4 books, My car traveled 48 inches, just a little bit more. With 6 books, it traveled 69 inches, so quite a bit. Let me show you a picture of the ramps that I built. So you can see, since I'm testing height here, I didn't change the ramp itself. The surface is exactly the same, it's just cardboard. But I did change the height. I have 2 books stacked here, 4 books stacked here, and 6 books stacked here. So you can see the height or the level of steepness of my ramp changed. So when you're testing the height, you want to make sure that's the only thing that is changed, that the surface remains the same. Here is where I was testing the surface. I have cardboard for one of my surfaces, sand, and a fluffy rug. So you can see that's different than what was in the lesson, and that's fine. You will record how you test the surface of your ramp. Here's how far the car traveled. With cardboard, it traveled 53 inches. With sand, and remember I didn't change the height, I kept it at the same level, it only traveled 20 inches. And with a fluffy rug, it only traveled 17 inches. It hardly moved. So let me show you some pictures of those experiments and how I changed my ramp a little bit. Here's my cardboard ramp. You can see it's exactly the same as it was before, and I did a medium height. So I did 4 books for all of my surface experiments. Here is my fluffy rug. It barely moved on the fluffy rug. And here is my sand. I put some sand on top of that cardboard, kind of like a dirt road, and it didn't travel that far either, but it did travel farther than it did with the rug. So then I've got some information about my test, and you'll see that in your lesson in just a moment. I wrote, the height that made the car go farthest was 6 books tall. So my tallest ramp made my car travel the farthest distance. The surface that made the car go farthest was the cardboard. So I thought the cardboard was sort of just like a regular road would be for my toy car. So that was much better than the grassy rug and the sand or the dirt road that I also tested as well. All right, let's go back to your lesson and see what you'll do after your data table. So your data table will look similar to this one and similar to mine, but remember, you're going to put your own materials in that you used. After you do your test, here are some questions that you can answer. Then you're going to follow these steps in order. You're going to create that data table just like we just reviewed. You can use the one in this lesson as a model. You're going to test each ramp, and for each test, you're going to record that data in your data table and how far the car went. You're going to solve the problem by deciding which height and which surface made the car go the farthest. So here are some questions or some sentence starters that you can use in your science journal. The height that made the car go farthest was, you're going to write down the results of your test. The surface that made the car go farthest was, and you're going to write your results. Remember, you can also draw a picture if you'd like to as well. Here's another objective. In this lesson, you will improve your ramp design. So you've designed it, but now you're going to see if you can do anything to make it even better. This is the last step in the engineering process. So ask yourself, what changes will you make to improve your design? Now you will improve your best ramp. So you want to start with the one that worked very well, the best, and then you want to try to make it even better. Build your ramp using the best height and surface. You decided on these in the last part of the portfolio during the test step. Then try the ramp. Measure how far the car goes and write down this measurement. Think about how you can improve your ramp. When you improve something, you change it to make it better. Down here, select this button, then select each pin to learn more about how you might improve your ramp. So down here, there are these little pins, and if you listen, it will discuss each one and kind of talk about some changes that you might want to make. All right, so here are some questions you can go over to talk about improving with your learning coach. And then follow these instructions in order. Earlier in this section, you thought about ways to improve your ramp. Now build your improved ramp. It is important to test your improved ramp. In the engineering design process, you can repeat the test and improve steps over and over. Test your improved ramp and measure how far the car goes. Write down this measurement. Compare the measurements from the 2 tests. How far did the improved ramp make the car go compared with the earlier ramp? Did your changes make the ramp better? If not, think about why not and try again. Make your very best ramp. Finally, write about your very best ramp in your science journal and include a drawing or photo. So here is where are some sentence starters that you can use in your science journal. An improved ramp makes the car go. I improved my ramp by. I tested my ramp by. And then you can draw your best ramp in your journal as well, or you can take a photo. So here is my improved step in my science journal. I wrote, I improved my ramp by flattening and smoothing it out. So cardboard was my best surface, but I noticed there were some bumps that were creating some friction. So I smoothed that out as best I could. And when I did that, my car traveled even farther. And that's what I wrote next. It worked and my car went farther. So when you improve, if it doesn't work at first, that's absolutely okay. You just want to try something else. Mine worked the first time, so I kept that improvement and I didn't make any others. We are almost done. In this portfolio, you use the engineering design process to solve a problem. You wanted to find out which ramp height and surface would make the toy car go the farthest. So here's the process. You did all of these steps. Well done. First, you asked questions about ramps, you brainstormed ideas, then you designed and created your ramps. You tested each ramp and measured how far the car went each time. You used what you learned to make the best ramp, and then you made changes to improve it. Now you're going to think about your portfolio project, and you're going to look at what you've already written in your science journal. Now you're going to reflect. Reflect means to think and talk about your portfolio project with your learning coach. You can use these sentence starters for help. You can write your answers in your science journal. If you have any new questions, you can also record those. So here is my example. I learned that steep ramps help things move farther. The most difficult part was testing many different ramps. I had to build and unbuild and rebuild. It was a lot of work. I'm sure you experienced that too, but I also think it was fun. Then I said I thought like an engineer when I planned different surfaces like roads. So instead of just doing toy ramps, I wanted my surfaces to almost seem like roads that real cars would go on. I thought that that was pretty cool, like a real engineer. Maybe a real engineer could do a test like that before they built a new road surface. All right, let's go back to your lesson. So after you have added these to your science journal, that is the last step. Here are all of the things you want to make sure you include and turn in for a grade. In your science journal, you need your ask questions section, your brainstorming section, your design and create section, your data table, your test, your improve section, and your final reflection. You can draw pictures and you can write sentences throughout that science journal. And remember, if you take any pictures, you can also include those if you take any pictures of your different ramps. So once you have all of that complete and organized, you're going to take pictures of those pages and turn them into your teacher for a grade. If you need to go back and look at the I Can rubric, it's going to be on page 14 in the Science 2 resource book, all right? So you can look at that rubric just to make sure that you've completed all of the steps. I know that you're going to have a lot of fun doing this portfolio, and I hope you get the very best grade. I will see you next time. Thanks so much for watching. Goodbye.